Okay, so we've been talking about circular motion in terms of arc length and angles, as long as the angles are measured in radians. However, we can relate these concepts to the idea of centripetal acceleration and centripetal force. If you recall, the centripetal acceleration of an object was equal to v squared over r. Now we just derived an equation, which we've written over here, that says that the speed with which the object travels around the circle is equal to omega times r, where omega is the angular speed of the object measured in radians, angular speed meaning how fast does this angle theta change over time. So if we plug this in, we get the centripetal acceleration is equal to omega times r squared over r. And then if we square that out, we get omega squared r squared divided by r, which then simplifies into omega squared r. And that's the centripetal acceleration written in terms of the angular speed of the object as it moves around the circle. Now, in terms of force, we know that Newton's second law says force is equal to mass times acceleration, and so we can replace the acceleration in this equation with omega squared r, which is the acceleration. So centripetal force is going to be equal to m omega squared r. So now we have an equation for the centripetal force, but in terms of the angular speed of the object as it moves around the circle. So we are going to come back and use these quantities. We'll do some calculations and solve some problems using these things, and we'll look forward to the next time that we can have a video together.